Let's take a look at this example of overbooking. An airplane sold all tickets on a 150-seat plane. Given that 98% of the passengers show up for their flight, find the probability that all 150 people show up for their plane. So this is a real situation, guys. Usually there is a statistics on how many people actually show up for their plane, and it's very seldom that 100% of people show up. So let's say that statistics says that normally, on average, 98% show up. So what's the probability that all 150 people show up? So we're looking at every individual person and figuring out, did they show up or not? Well, this is our Bernoulli trials with n equals 150 and the probability of success of 98% or 0.98. Well, it would be useful for us to know the probability that the person will not show up, the probability of failure, which is a complement. So we're going to have 0.02 for Q. So to figure out the probability that all 150 will show up, the probability of success is 150. We're gonna do NCR formula, 150C 150, multiplied by the probability of success to how many successes we observed, times the probability of failure and how many failures we observed. Okay, so putting this in the calculator, well, this is 1. This is 1. So we only have 0.98 to power 150, and that gives us 0.048296. Okay, so this is the probability that all 150 people will show up, and would that be unusual? That's our question. And the answer is, looking at the probability, remember I told you that if the probability is less than 5%, that's an unusual event. So here we have a probability of 0.48, which is close to 5%, but not exactly. So I would say this is still an unusual event. Well, let's proceed to question B. Find and interpret the expected value. So the expected value would be, it's the same as the mean. So n times p, 150 times 0.98, and that gives us 147. So what does that mean? What does that value represent? That value represents the number of people that we expect to show up for plane. We sell 150 tickets, then we expect 147 people show up. All right. So, and that is exactly why usually the companies sell more tickets than they have seats. Okay, so let's proceed to the next part of this question. It says, an airplane sold an extra 3 tickets on 150-seat plane. Given that only 98% of people show up, find the probability that the airplane will have seat for everyone who shows up. So if the airplane has seats for everyone, that means that no more than 150 people show up, right? So we're looking for the probability that X is less or equal to 150. Okay, so now if you think about the probability that we need to figure out, we need the probability that 150 people show up, right? Or the probability of 149 shows up, or the probability of 148 shows up, and so forth up until 1. So this is a cumulative probability, right? In this case, it would probably make more sense to find the complement of this event and subtract it from 1. What would be the complement for at most 150 people showing up? Well, that would be, pause here if you need to think about it, because I'm going to give you an answer in a second. And that's the probability of X being greater than 150. So what does that mean? Let's break it down. That's the probability of X being 151 or 152 or 153. So we're gonna run our binomial probability formula 3 times for these different X values. And don't forget to change your N now is to 153 instead of 150, and the probability of success is still the same. So we're going to have to calculate the probability of X is 151. It's going to be 153 C 151 times 0.98. How many successes? 151. How many failures? 2 plus, and then we're gonna do that for the rest for the other 2 values. So after you plug all of these values into your calculator, you should get 0.4075311. So what do we do after we found this probability? Well, remember that that probability was a complement of what we actually were looking for. So we need to subtract it from 1. So the probability that 150 or less people show up will be 1 minus 0.407 531. And that is 0.592469. Okay, guys, this is it for this problem. If you have any questions, let me know during our lecture.